In this video, we're computing the integral of 1 over x plus pi. Now this quickly integrates to a natural log function, and in a sense, that's not even the interesting part of the problem. What we're going to do after this is check our work by differentiating the antiderivative that we get, and it gets into the details of what to do with those absolute value bars in the natural log function. So we start by just remembering how to get the antiderivative here, and it's just the natural log of the absolute value of this denominator. For generality, we put in the plus c on that. And this is really just the base formula that you should have memorized for how to integrate 1 over a variable. Now the interesting part is actually in checking our answer. How do you deal with the absolute value bars? And the approach we always take to the absolute value function is to split it into cases. Just as a reminder, the absolute value of x does nothing if x is greater than or equal to 0. So the absolute value of x is x if x is greater than or equal to 0. The absolute value of x multiplies by -1 if it sees a negative number. So it's negative x if x is less than 0. So what about the absolute value of x plus pi? That's going to do nothing provided that x plus pi is greater than or equal to 0. So again, the absolute value here does nothing. It leaves the argument alone as x plus pi, provided that x is greater than or equal to negative pi, guaranteeing that x plus pi is non-negative. Now the absolute value will multiply by -1 if it sees a negative argument, and that would happen if x is less than negative pi. So to find the derivative of our antiderivative here, we have to split into these two cases, and we say when x is greater than or equal to negative pi, my antiderivative is simply the natural log of x plus pi, no absolute value bars, plus an arbitrary constant c. What about when x is less than negative pi? Well, the antiderivative is going to be the natural log of the negative of x plus pi, because x plus pi is negative and the absolute value multiplies by -1. So to check that the antiderivative is correct, we differentiate it and see if we get back to what we started with. So in the first case, we have the derivative of the natural log of x plus pi plus c, and we know the derivative of the c gives us 0. The derivative of the natural log of x plus pi is just 1 over x plus pi. And to be extra cautious, I'll mention that we have to multiply by the derivative of x plus pi. In other words, we have to use the chain rule, but that derivative is just 1. So the derivative of my antiderivative comes out to my original integrand, and I'm happy. Now what about the x is less than negative pi case? In that case, our natural log function is the natural log of the negative of x plus pi. Again, the derivative of the plus c vanishes. And when I get the derivative of this natural log, I get 1 over the argument of the natural log, which is the negative of x plus pi, again, multiplied by the derivative of that argument. So I'm using the chain rule here. Well, what's the derivative of the negative of x plus pi? It might be easier to see if we looked at it as negative x minus pi. The derivative of that is the derivative of just negative x, which is -1. These factors of -1 cancel, and I get the exact same derivative of my antiderivative, 1 over x plus pi. So that's a nice little review of what those absolute value bars are about in this antiderivative. And the essence of it is just that the derivative of natural log x and natural log negative x are just the same thing, 1 over x, because of the way the chain rule works. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.